Welcome back. This is the 6th video for Chapter 7, Arrays. In this video we're going to be talking in general about two things, sorting and searching. And we will look in particular at algorithms or an algorithm to do searching. We'll do an algorithm for sorting in the next video. Well, anytime you're dealing with arrays or big collections of data, there are a couple of common problems that pop up again and again and again. One of those problems is searching. So given a target value, we want to find out, is that value in the array? And if it is, where is it located? An example would be, if you imagine logging on to a website, you provide a username. We need to search to see if that username is in our list of registered users. Now in real life that would probably be done with a database rather than array, but the concept is similar. Another very common problem is sorting, and that's where you're going to rearrange the values in an array into some order, perhaps alphabetical, maybe numeric, so we'll have it be ordered in increasing numeric value, all kinds of different ways that you could think about sorting something. An example here would be arranging all the font names on your computer into alphabetical order, particularly in processing, so they could pop up in that list of fonts that we get when we create fonts for our processing programs. Now in this video, we're really going to focus on what's called a linear search. And a linear search is something that we did previously in another example in this chapter. But let's review it here, look specifically at the algorithm, and go through an example. So our strategy is to look at every element in the array in turn. If the current value that we're looking at happens to be our target, we're going to return its index. If, on the other hand, we reach the end of the array without finding our target, we're going to return a -1. And that -1 is sort of a special flag value. And that means that the item that we're looking for isn't in our array. The reason we choose -1 is because it's an invalid index for any array. Here's an algorithm for doing a linear search. So in this case, we're going to have two parameters. ARR is the array that we're searching for, or searching through rather, and target is what we're searching for in that array. So in the loop, which runs from here to here, we're going to look at everything in turn, and then we ask a question. Is the item that we're looking at equal to our target? And if it is, we'll send back the index where that element occurred. On the other hand, if we get through the entire array, ask that question about every element in the array, and never find what we're looking for, then at that point we'll be done with our loop, and so the next statement would be return -1, and that means the item that we're looking for wasn't found. So here's an example. This is going to be a situation where we're going to find the item that we're looking for in our array. Okay? Now it's important to realize, however, that our computer, when it's examining something, can only see one element at a time. So when it's starting out, for instance, it's going to be looking at the first element, and it has no idea about anything else. It can't see this, or this, or this, or this, or this. Just one element at a time. So the first question then that the computer is going to ask is that it? Is the 13, which is at spot 0, our target? It isn't, so we'll continue to the next element. Now we ask, is that it? Is item I equals 1, is that equal to our target? Well, it's not, because 67 isn't equal to 70, so we move on. What about this? Is that it? Nope, because 52 isn't 70, so we move on. Is that it? No, 79 isn't 70, so we move on. And lastly, we ask, is that it? Well, yes, it is. The item at element 4 is 70, so we return 70. I'm sorry, we return 4, the index where that item was found. Now let's look at a not found case. Again, the computer doesn't know that it's not found. We're looking for 16, but it can't see the whole array at once, so it looks at this spot only. And so we start asking questions. Is that spot my target, 16? No, it isn't, so I'll move on. Is this spot my target, 16? No, it isn't, so we'll move on. And you see where this is going. Every time we look at an element, we ask the question, and it's not there. And we keep looking until eventually we've checked everything and not found it. And now our while loop will go one more spot, or for loop rather, and we'll look at the index I will be 1 past the end of the array. That causes the for loop to exit, and so we'll send back our -1, and again that's a special flag value which indicates that that item, 16, sorry this should be, was not in our array. Okay. There will be another video that looks at a more fully developed example, and that is the critter race application. And so the concept there is that we start with a line of little critters over on the left, and then they all start racing toward the right, and then we use a search to determine if one of them crosses the finish line. So that example from the book will be developed in another video.